Welcome. In this presentation, we will review association rules using R. In this presentation, we'll explore the fascinating world of association rules, a crucial concept in data mining and machine learning. Association rules are powerful tools that help us uncover interesting relationships within datasets. In our journey today, we'll learn how in the R programming language, we can leverage robust libraries to define and extract association rules efficiently. Let's start with the basics. Association rules are patterns that describe relationships between variables in large datasets. Think of them as if-then statements, where the presence of one set of items implies the existence of another set. Now, let's break down the key components of association rules. The antecedent represents the items present before the implication. It sets the initial conditions or factors that trigger the association rule. On the other side, the consequent comprises the items that follow the implication. It illustrates what is likely to occur or coexist based on the presence of the antecedent. Support measures the frequency of occurrence of the association rule within the dataset. A higher support value indicates a more prevalent and potentially more significant rule. Confidence gauges the likelihood that the association rule holds true. It provides a measure of how often the consequent is observed, given the presence of the antecedent. Higher confidence values imply stronger associations. In summary, association rules empower us to decipher complex relationships within data. Now, let's see how we can apply this knowledge using the R programming language. Association rules are key for making smart decisions and developing effective strategies. Association rule mining helps uncover hidden relationships and patterns in data that might not be obvious. We can discover valuable insights by connecting seemingly unrelated variables. Understanding associations in data allows businesses to improve their strategies. For example, in retail, knowing which products are often bought together helps with better product placement and marketing. Association rules are essential for market basket analysis, showing which items are frequently purchased together. This knowledge is useful for managing inventory, cross-selling, and planning promotional campaigns. In summary, learning association rules gives us the tools to understand our data better. It helps us find hidden patterns, optimize strategies, and make informed decisions. Let's delve into the practical applications that make association rules a valuable asset in decision-making and strategy implementation. When it comes to making decisions, incorporating association rules provides additional context. Businesses can enhance their decision-making processes by considering observed patterns and trends in their datasets. This additional layer of insight ensures more informed and strategic choices. Association rules play a crucial role in various industries, particularly in detecting anomalies and potential fraudulent activities. Unusual patterns in transactions or behaviors can be flagged for further investigation. This application is vital for maintaining the integrity and security of systems. E-commerce platforms and recommendation systems leverage association rules to deliver personalized suggestions to users. By analyzing past behavior and preferences, these systems enhance user experience, providing recommendations tailored to individual tastes and preferences. Efficient resource allocation is a key aspect of any successful operation. By understanding associations between different factors, businesses can optimize resource allocation. For example, in healthcare, identifying factors contributing to specific health outcomes enables more effective allocation of resources. In conclusion, the versatility of association rules extends beyond uncovering patterns. It actively contributes to decision support, fraud detection, personalized recommendations, and resource optimization. As we continue our journey, feel free to engage with any questions or thoughts you may have on these practical applications. Let's explore further. As we venture into the realm of association rule mining, understanding the metrics provided by the summary function becomes paramount. These metrics offer us valuable insights into the quality and significance of the association rules generated. Support acts as our guide to the frequency of a rule's occurrence in the dataset. In simple terms, it tells us how common the rule is. A higher support value indicates that the rule is prevalent in the dataset, making it more noteworthy. Confidence provides us with a measure of the rule's strength. It answers the question, how likely is the consequent to occur, given the antecedent? Higher confidence values signify stronger associations between the antecedent and consequent, indicating the reliability of the rule. Lift introduces a crucial perspective into our analysis. It measures how much more likely the consequent is to be purchased when the antecedent is present, compared to when the items are bought independently. A lift greater than 1 indicates a positive impact on the likelihood of the consequent, emphasizing the significance of the rule. Leverage measures the distinction between the observed frequency of the rule and what would be expected if the items were independent. A positive leverage value suggests that the items tend to co-occur more frequently than expected, revealing interesting patterns in the dataset. Conviction serves as an indicator of how dependent the consequent is on the antecedent. A high conviction value signals a strong dependency between the antecedent and consequent, underlining the influence of the antecedent on the occurrence of the consequent. As you navigate through the summary output, pay close attention to these metrics. They offer a comprehensive view of the association rules, allowing you to gauge their significance and reliability. Additionally, don't hesitate to experiment with different support and confidence thresholds to tailor the rules to the specific needs of your dataset and objectives. Here, we're diving into the practical aspects of applying association rules using the R programming language. Let's walk through the steps, starting with the essential tools and libraries. R equips us with robust libraries for association rule mining, and among them, the most popular is the Arules package. This package provides a comprehensive set of functions and tools for efficiently defining and extracting association rules. Before we start, we need to make sure the Arules package is installed. Uncomment the install line if it's not installed yet. Once installed, we load the package into our R environment using the library Arules command. This gives us access to all the functionalities within the Arules package. The foundation of association rule mining is having your data in a transaction format, where each row represents a set of items. In our example, we'll use the groceries dataset, a classic dataset for association rule mining. We create a transaction object using the as function, converting the groceries dataset into a format suitable for association rule analysis. This step is crucial, as it sets the stage for generating meaningful insights from our data. Let's delve into the process of generating association rules in R. This step involves utilizing the a priori function from the Arules package to generate association rules. The code snippet provided demonstrates how to execute this process. The a priori function takes the transactions as input and allows you to set parameters such as support and confidence thresholds. It's crucial to adjust the support and confidence thresholds based on your specific dataset and objectives. These thresholds influence the rules generated, and finding the right balance is key to obtaining meaningful insights. As we progress through this journey, feel free to experiment with different parameter values and explore how they impact the association rules you generate. Questions are welcome as we continue our exploration of association rules in R. Now that we've generated our association rules, the next step is to explore and evaluate them. Let's understand how to interpret and assess the rules we've generated. This step involves gaining insights into the generated rules using various metrics. The provided code snippet utilizes the summary function from the rules package to present a comprehensive overview of the generated association rules. This summary includes essential metrics and statistics that help us assess the quality and relevance of the association rules. As we run this code, pay attention to metrics like support, confidence, and lift. They provide valuable information about the strength and significance of the discovered associations. Feel free to ask questions as we navigate through the exploration and evaluation of association rules in R. The results of our association rule mining, as summarized in the output. This set of 581 rules provides valuable insights into the relationships within our dataset. Let's break down the key aspects for better understanding. The distribution indicates the number of items on both sides of the association rule, LHS plus RHS. We have 59 rules with 1 item, 426 rules with 2 items, and 96 rules with 3 items. The majority of rules involve 2 items with an average rule length of approximately 2.06. These measures give us a snapshot of the characteristics and significance of the association rules. The minimum support is around 0.01, indicating that the least frequent rule appears in about 1% of transactions. The maximum support is around 0.26, suggesting that the most prevalent rule occurs in around 26% of transactions. Confidence values range from 0.02 to 0.59. Higher confidence indicates stronger associations between the antecedent and consequent. Lift values vary from 0.79 to 3.37. A lift greater than 1 suggests a positive impact on the likelihood of the consequent. The count provides the actual occurrence of each rule, ranging from 99 to 2513. Finally, the mining information gives us context about the dataset. The dataset contains 98835 transactions. The support threshold is set to 0.01, and the confidence threshold is set to 0.02. In summary, these metrics provide a comprehensive view of the association rules. The support, confidence, and lift values offer insights into the strength and significance of the rules, while the count reflects their real-world occurrence. As you explore association rules in your analysis, consider adjusting support and confidence thresholds to tailor the results to your specific needs. In our journey of applying association rules in R, we've reached the exciting part of visualizing the rules we've generated. Let's explore how graphical representation enhances our understanding of these associations. Visualization is a powerful tool for gaining insights and a deeper understanding of the association rules. The provided code snippet introduces the rules library, which allows us to create visual representations of our rules. This code generates a graphical representation of the association rules, making it easier to identify patterns and relationships. Now, let's bring our understanding of association rules to life with a practical example. Imagine we have a retail dataset similar to the classic groceries dataset, where antecedent items represent products that are frequently purchased together. Consider the association rule, coffee, greater than or equal to bread. This rule suggests that customers who buy coffee are also likely to purchase bread in the same transaction. Association rules, such as this one, provide actionable insights for businesses. By understanding these patterns, businesses can optimize strategies. For instance, in a retail setting, knowing that coffee and bread are often bought together can inform decisions about product placement or targeted marketing. Leveraging the capabilities of R for association, rule mining empowers analysts and data scientists to uncover valuable relationships within their datasets. It's a powerful approach to gaining insights that can drive informed decision-making.